Hi all. In this class we are going to find the capacitance of two-wire transmission line. In previous class we studied the capacitance of coaxial cable. So first we can understand how we can find the capacitance of any geometry. So to find the capacitance of any geometry, first we need to assign a suitable coordinate system. After selecting a coordinate system, we need to provide the conducting plates with plus q and minus q charges. After giving these charges, that configuration act as a capacitor. Then we need to find the electric field intensity using Coulomb's law or Gauss law. After finding E, we need to find the potential V is equal to negative line integral of E dot dl. Then after finding this potential, we can easily find the capacitance using the expression C is equal to Q by V. So here our aim is to find the capacitance of two-wire transmission line. So in figure we can see a parallel wire transmission line consisting of two conducting cylinders having radius A each, and 2h is the separation between their centers. So in figure we can see a two-wire transmission line. It consists of two parallel conducting cylinders having radius A each, and the separation between these two cylinders is 2h, and the difference between the potential among them is called VPP dash. So to find the potential difference and hence capacitance, we use the result of potential due to parallel wires of charge density royal and minus royal. So to find the capacitance of two-wire transmission line, we use the result of potential difference due to parallel wires. So we need to remember this equation, that is the potential due to this parallel wires, because we are not deriving the expression for the potential difference due to parallel wires, just we are using this expression only here. So the potential difference due to parallel wires having density royal and minus royal. So we are assigning that one conductor's density is royal and another conductor density is minus royal. Then what is the potential difference between these densities we are finding? That is VPP dash equal to royal by pi epsilon 0 log of k. So where k is R2 by R1, that is the ratio of position vector of two parallel wires. So we are taking two parallel wires, and using that result we are going to find the capacitance of transmission line. So for a parallel wire, the potential difference between these two parallel wires is VPP dash equal to royal by pi epsilon 0 log of k, where k is the ratio of position vectors of two parallel wires. Position vector of first line is taken as R1 and the second line is taken as R2. Then the ratio of R2 by R1 is known as this position. R2 by R1 is known as the K value. Then the potential difference VPP dash equal to royal by pi epsilon 0 log of K. So if we are obtain this potential difference, then you can easily find the capacitance using the relation C is equal to Q by VPP dash. But this is the result for a parallel wire. We need to find what is the potential difference of a two-wire transmission line using this result. So for that, we are finding what is the relation of K with our two-wire transmission lines parameters like H and A. So to find the potential difference of a two-wire transmission line, we are finding the relation of parallel wires parameter with the transmission line parameters, that is the relation of K with H and A. So the relation of K with H and A is given as A equal to 2kd by k square minus 1 and H is equal to D into k square plus 1 divided by k square minus 1, where D is the coordinate of R1 and R2, that is D comma 0 and minus D comma 0 respectively. So D represent the coordinate of R1 and R2. So using these two equations, we are finding a quadratic equation. So for that we are finding what is D value from this first equation, that is A equal to 2kd by k square minus 1. then that D is replaced in second equation. So from first equation we are finding what is D, and that is replaced in second equation. Then after solving this, you will get a quadratic equation like k square minus 2kh divided by a plus 1. So we can see that it is a quadratic equation in k. So it is a quadratic equation. So we have two roots that is represented as k and k dash. So finding this root, you will get it as using the equation minus b plus or minus root of b square minus 4ac divided by 2a. So after using this equation, you will get it as k comma k dash, that is two roots are 2h by a plus or minus root of 2h by a whole square minus 4 whole divided by 2. So we can see that 2 is common in every term, so we can cancel it. So the final result is h by a plus or minus root of h by a whole square minus 1. So now we have two roots. One is k and another one is k dash. That means one is a plus and another one is a minus root. That means h by a plus root of h by a whole square minus 1, and the another one is h by a minus root of h by a whole square minus 1. So in this two equation, we are selecting the root, the positive root, that is h by a plus root of h by a whole square minus 1. Then we can easily replace our VPP dash. So the VPP dash equation is rho L by pi epsilon 0 log of k. So now we select the k as h by a plus root of h by a whole square minus 1. So we have VPP dash equal to rho L by pi epsilon 0 log of h by a plus root of h by a whole square minus 1. So now we got the potential difference. Then we can easily find the capacitance per length. So capacitance per length is equal to we can find the capacitance per length as rho L by VPP dash, or capacitance is Q by V. We can replace Q as rho L into L. So this Q becomes rho L into L by V, or capacitance per length is rho L by V. So here V is VPP dash. So we can replace VPP dash as rho L divided by rho L by pi epsilon 0 log of h by a plus root of h by a whole square minus 1. So rho L cancel. So remaining is pi epsilon 0 by log of h by a plus root of h by a whole square minus 1. And here we found the capacitance per length. So the unit is farad per meter. So this way we can find the capacitance of two-wire transmission line. So remember, to find the capacitance of a two-wire transmission line, we are approximating the result of parallel wires potential difference. Then we finding what is the relation between the parameters of parallel wires and the parameters of transmission line. From that we are developing a second degree equation. Then we are solving that second degree equation. From this solution we are finding what is k. Then we are replacing VPP dash is equal to rho L by pi epsilon 0 log of k as rho L by pi epsilon 0 log of h by a plus root of h by a whole square minus 1. Then after that we have find the capacitance as capacitance is Q by V, or capacitance per length is rho L by V. So we can replace V as VPP dash. So rho L by VPP dash. Then after simplification, you will get the capacitance per length of two-wire transmission line as pi epsilon 0 by log of h by a plus root of h by a whole square minus 1. So that's all about the capacitance of two-wire transmission line. In next class, we can find what is the inductance of two-wire transmission line.